Hello friends, in this video we are going to discuss about the circular queue, which is another data structure which is quite similar to the normal linear queue data structure which we have discussed in the earlier videos. But in this video we are going to implement the queue as an array, but the array will be a circular array, not a linear array. So in that case, if we use a circular array to just explain or implement the concept of the queue data structure, we will just show it by means of the circular queue data structure. So in the case of circular queue data structure, what we will take, I will just show you by a pictorial representation on the board and show you how the circular queue works and what are the primitive operations associated with it. I am going to discuss about those as well, like that the add operation and the delete operation, which we have already encountered in our previous videos about the queue data structure. So let's just draw the structure of a circular queue and give you an overview of how that thing works. So suppose I take this like this. Suppose there are some positions here. Let me just give the number 0, 1, 2, 3, 4, 5, 6, 7. Suppose there are 8 cells in this array. This is an array which is definitely which can be easily understood rather that this array is called a circular array because it goes in a circular fashion. That is, it is starting from 0 and ending at the same point where it started. So this is in a circular fashion we have implemented an array. So this is a circular array, and with the help of this we are going to discuss about this circular queue data structure. How does that work in this circular queue data structure? Suppose we may imagine that this circular array contains some elements over here, over here, over here. So let me just recapitulate or let me just recollect some of the ideas which we have learned in the queue data structure, queue as an array, that explanation part, what is the front, what is the rear in this circular queue. Those are quite similar to one we have discussed in the earlier videos regarding queue. So in this case, see, suppose if the length of the queue is 3, that is, it starts from 2 and 3, 2, 3 and 4, it goes like this. So the length is easily understood to be 3. So in this case, the front will be always 1 less than the index of the beginning of the queue, as we have maintained in the previous videos. So I am going to maintain the same concept, that is, front will be always the index position, which is 1 less than the beginning of the index of the queue. So in the beginning of the index of the queue is in this case 2. So the front in our case, our example will be this one. So front will contain a value 1 because this 1 is 1 less than the beginning of the index of the queue, which is 2, and rear will be nothing but the index of the last element in the queue. So this will be rear. So front will be 1 and rear will be 4 in this case. So if we just do this calculation, rear minus front, this is quite similar to what we have studied in the queue data structure. That is, rear minus front is 4 minus 1. So 3. So see this. The length of the queue is 3 because there are 3 elements in the queue data structure in this circular queue. So in this case, we are also going to perform the similar operations of add, addition and deletion, but in this way, that is in a circular way, so as to implement the queue in a circular array fashion. So in this case, we also need to define the structure of the queue, just like we have defined previously, like type def struct. Suppose I name this as CQ. Type def struct CQ What will be there? There will be one data part, there will be an array, and that array will have two pointers, not two pointers, to an integer associated with it also. That I will take the array like this. Suppose the array is int a 1000. I will take one array, that is this array, and I will take int front, comma, rear. So these are the basic things which are required in the queue. That is the array, and front and rear are two integer variables which will hold these values. That is the index positions of the front and the rear positions, and we define it as CQ. So this is the structure definition of circular queue, and after this I am going to perform the addition operation in the queue first, and then I will go on to describe the deletion operation. So first let's write the addition function, that is the algorithm for addition of an element in the queue. So let's get started with writing the addition function after rubbing off this portion. So suppose I will write like this: int add CQ. So suppose this is the function name which I have given in my example, that is int add CQ. Add CQ means I am just trying to show you that we are performing the operations of addition, on the circular queue. So this CQ means circular queue. You can just imagine in that way. So you can write any other name of your choice, but I am just using it like this to make you understand in a very simplistic manner. Int add CQ, and whatever is what will be the arguments, formal arguments in this function definition. Obviously, the formal argument should be one item that is going to be inserted into the queue. That is, suppose int a, and a queue data structure, that is, and a queue pointer, and a pointer to the circular queue data structure. That is, I have named the circular queue data structure like this: CQ star, say about q, and after that I will write one integer variable int t. So now what I will do, I will write like this: t is equal to q rear plus 1% 1000. What I have written? Q rear plus 1% 1000. That is q rear plus 1 modulus operator 1000. That is, we are incrementing the q rear position by 1 because we have to operate in a manner so as to pre-increment the rear in the case of addition in the queue, as we have seen in the other queue as an array, or a queue as a in the queue as an array, linear array. We have seen that the rear should be added by unity to make it incremented so that it creates some space for addition of a new element from the rear end, that is from the back end of the queue. So we are incrementing this q rear plus 1, but we are doing this increment operation not in a straightforward fashion because we are dealing with circular queue. So since we are dealing with circular array, we are incrementing this q rear position by unity, but modulo 1000. Because why 1000? It could have been any other value as well. But since we have taken our array to be having a maximum of 1000 elements, so that's why I've used this maximum size which we have used in the dimension declaration of the array. So if we would have taken an array of 100 elements, we could have given 100 over here, or 10,000 elements for 10,000 elements, 10,000, and so on. So what is the maximum dimension of the array which we have taken in the data structure definition? That maximum dimension is to be written over here in order to perform the addition or the increment operation, that is the pre-increment which we are doing in a modulo 1000 manner in our case. So this is the first line of code I have explained to you, and now I will just put a check like this: if q front equals, if q front, sorry, if t equals q front, if t equals q front, then we will not be able to, suppose we will write a message in this case. In this case, see this, if t becomes equal to q front, that is, we are having some element which is, we are now going to add q, we are going to add to the q. So, in this case, if t equals q front, this condition holds, then it is nothing but the q full condition. So, then it will be the q full condition in which we will not be able to insert any further element to the q because the q is already full. So, in that case, we will just write a message like this, printf q is full. Then we will return 0 to indicate that the operation is not successful. It is a failure operation for which we have taken a return type of integer data type. So, this is the first part, and now we will come on to the general part after this. So, the next line is q rear will be the incremented q rear which we have assigned into the incremented value of q rear is being assigned to this t, and now q rear will be updated by this t by assigning the value of t into q rear, in which in this case we are now incrementing the q rear by one position modulo 1000 in our case. So, after this what we are left to do is nothing but to insert the element. If the q is not full, in that case we are writing this code, and in that case we are going to insert this, the element, that is a, int a, which we have taken in the formal argument, into the q rear position created by incrementing the q rear position by unity modulo 1000. So, I will write like this, q a, that is the name of the array, q rear is equal to a. So, this is the operation of addition of element from the rear end to the q, rear end of the q rather. So, this is q arrow a means we are holding the array which is the part of the q data structure. Into that we are writing the index position of this array by means of writing this this portion, that is q rear. So, q rear is equal to a makes us add this element a into the rear position of the q during the addition process. After this we are left with only one statement, that is, since this is a successful operation we have performed, we will just return 1 from this after this. So, I will just return 1 after this line and end the function body. So, this is the addition function or the addition algorithm written in the form of a C function for the addition operation in a circular cube. So, suppose I will just make you understand by a simple example. Suppose the q is in this condition, we are going to add one element a, and that a is to be added to the rear position. How will we do that? See this t is equal to q rear plus 1%. This q rear, now t will become what? Q rear means 4. So, q rear plus 1 means 4 plus 1% 1000, that is 4 plus 1 modulo 1000, that means 5 modulo 1000, that means 5. So, now t becomes 5, and now we will check if t is equal to, if t equals q front. See this, t is 5 but q front is 1. So, it is not equal, so both of them are not equal. So, this is not the full condition. Q full condition is denoted by this this position. This is the q full condition, and we are seeing that our q is not full because you can easily see there are many vacant spaces over there. So, in this case we are seeing that the q is not full. So, we are going to add some element from the rear end to the q, and in this case we are going to skip this portion of this algorithm and come to the next generic portion of the algorithm by writing like this: q rear is equal to t. What is q rear now? The updated q rear will be whatever is in the value of t, that is 5. So q rear becomes 5, and now q rear is equal to a. What is q rear? q a. And what is q rear? Q rear value is updated to 5. So it is the 5th index and is equal to the new element a. So this is the assignment operation which we have performed in this line, and this 5 position is this one, and whatever is to be added to the rear end of the queue, that is the a element, is to be added in this position, and the queue becomes larger by 1 length. So in this case we have performed our addition operation in the rightful manner. After that we have returned 1 to indicate that the operation was successful. So I am now going to write the delete function. We have already discussed the addition function in the circular queue. Now I am going to write the C function for the delete operation. So let's write the code like this. We'll write int del cq. I will write the name of the function like this, del cq, in order to just make you understand that we are dealing with the delete operation on a circular queue. So in del cq we will write like this: int star a and cq star q. Now what we are going to do is to check whether the queue is empty, because we are going to delete from the queue, and if the queue is empty, then naturally we will not be left with an option to delete any element from the queue, because the queue is empty. So in order to rule out that possibility, or in order to deal with that situation, I am going to write the check for that empty condition of the queue. And you know very well that the queue empty condition is nothing but when the front it becomes equal to rear. So this is the condition of the queue full condition. So this is the queue empty condition rather, very sorry. So queue empty condition is nothing but front equals rear. So we are going to write this condition over there as to check whether the queue is empty, and in that case it will prevent us from the deletion of any element from the queue. So we will just put a check like this to check whether the queue is empty by that condition. Queue front equals queue rear. So if queue front equals queue rear, that is front equals rear condition holds, then it means that the queue is empty and will not be able to delete any item from the queue in that case. So I will just put a message. I'll just print a message by this expression statement. The queue is empty, or deletion is not possible. Anything you may write in this position, in this expression statement. And after that, since we are not going to return, or we're not going to delete any item from the queue, so this pointer this a pointer will be set to null. A is equal to null. So a is equal to null, and after that, since it is a failure operation, we will return 0. Else, if this condition doesn't hold, that is if the queue is not empty and at least contains one item, so we can delete that one element from the queue. In that case, suppose in this case we are having 4 elements, and if the queue would have contained only one element, we could have performed the deletion operation once. So in that case, if we have minimum one element in the circular queue data structure, we can delete one item at least from the queue. So that operation I will write it in the form of the expression statement. Let me write that, because in that case what we'll do, suppose in this case what we'll do, we will delete the first element of the queue. So first element is at index number 2, but front is in the position 1 less than the index of the beginning of the queue. So we will perform a pre-increment of front, just as we have done the pre-increment of rear in the case of addition operation. We will just pre-increment the front and take the front to this position and fetch this element in the number 2 position and delete that element and put it into star A. So that will be our operation. So first I will write like this: Q front is equal to Q front plus 1 modulo 1000. Here will be also modulo 1000 because we are doing a circular fashion. Q front equals is equal to Q front plus 1% 1000, and after that we will put the item into, we'll put the item in star A, that is whatever is in the Q front now. Q A Q front square bracket. So after this, since it is a successful operation, we will return 1, end the else block, and after that end the function. So this is the deletion operation. Suppose we are going to delete this one, front is over here, we are going to increment the front by 1 by this expression statement. Front goes here, and then we are coming to this number 2 position. Front is updated. We fetch this element and assign that into the pointer variable A in this format, that is star A is equal to Q A Q front. So we are taking the Q front item, the item at the index number Q front from the array A, that is Q arrow A. So Q arrow A, now Q front is how much? After incrementing front, it is 2. So Q A2 will be assigned to star A. So this is the sense which we are trying to get from this expression statement. After that, since it is a successful operation, we have returned 1, ended the else block, and then ended the function body. So if you have any doubts or queries pertaining to this entire explanation of the circular queue topic, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.